Hello, Hornets. Thank you for joining me today. Today, we're going to be taking a look at solving logarithmic or exponential functions that have multiple terms in them. So these are the most complicated ones that we have, and I'll only be doing about 2 or 3 of them with you now and leave you to do some more on your own. So we're going to be starting off with 5 to the power of 8x minus 3 times 3 to the 5th power equals 2 to the power of x plus 4 times 14 to the 2nd power. Now, in order to do this, we have to exponentiate. When we exponentiate, we put a single log in front of both sides. So we're going to put log in front of both. Okay, let me make sure I give myself the room to put that log in front of both. I'm going to have ln and ln. Now, I prefer the natural log. It has 2 letters, and that's really why. Some people may decide to use log base 10. Please choose only natural log or log base 10 as you want to use a common log. Alrighty. Now, because I have a logarithm and these 2 terms are a product, I can expand the log so that I have natural log of 5 to the 8x minus 3 power plus natural log of 3 to the 5th equals natural log of 2 to the x plus 4 plus natural log of 14 squared. Powers now move in front. 8x minus 3 to the natural log of 5 plus 5 natural log of 3 has to equal x plus 4 natural log of 2 plus 2 natural log of 14. We now have to distribute. We're going to distribute to both inside of each parenthesis. Notice 2 terms. Natural log of 5 has to be attached to both. So we have 8x natural log of 5 minus 3 natural log of 5. See how the natural log of 5 went behind both terms. This stays the same, and we repeat the process. Once again, this is of 2. So I have x natural log of 2 plus 4 natural log of 2 plus 2 natural log of 14. We now need to get the x's to the left and non-x's to the right. So this x has to move over. These 2 non-x's have to move over in the other direction. So we should get 8x natural log of 5 minus x natural log of 2 is equal to 4 natural log of 2 plus 2 natural log of 14 plus 3 natural log of 5 minus 5 natural log of 3. We're now going to factor out the x. So x gets factored, leaving me with 8 natural log of 5 minus the natural log of 2. And on the opposite side, everything is still the same as we write it all down again. Now, the hardest part is writing all of this extra stuff down. Now we divide both sides by 8 ln 5 minus ln 2. And I now have what x is equal to. This is my exact answer for ln 2 plus 2 ln 14 plus 3 ln 5 minus 5 ln 3 over 8 ln 5 minus ln 2. And there it is. That is my solution. Notice it's a lot of work. Now, the more you get used to this, the easier it becomes. Just remember that, okay? Let's take a look at the next one. 7, 4x plus 1, 12, 5. 3 to the 9x, 6 to the 3rd power. Put the ln in front. 7 to the 4x plus 1, 12 to the 5th. ln 3 to the 9x, 6 to the third, expand. 7 to the 4x plus 1, ln of 12 to the fifth, ln to the 3, 9x, ln 6 to the third, power moves in front. We're now going to move the pieces that are non-x's to the right. X's go to the left. So we've got to distribute this and then move pieces. So I have 4x ln of 7. I'm going to have this plus ln of 7 plus 5 ln of 12 equals 9x ln of 3 plus 3 ln of 6. And now I move things. 4x ln of 7 stays in where it is. We have minus 9x ln of 3. These move to the other side, so I have 3 ln of 6, and I subtract ln of 7, and I subtract 5 ln of 12. Factoring out the x, leaving me with 4 ln of 7, minus 9 ln of 3, still equal to that stuff on the other side, 3 ln of 6 minus ln of 7 minus 5 ln of 12. Now divide both sides by 4 ln of 7 minus 9 ln of 3. 4 ln of 7 minus 9 ln of 3. X then has to equal 3 ln of 6 minus ln of 7 minus 5 ln of 12 over 4 ln of 7 minus 9 ln of 3. That's our answer. That's what we're looking for. Now, there is a pattern here. Please take note. We have the 4 moving in front of the natural log of 7. 1 natural log of 7 moved to the other side. 9 ln of 3 moved to the left. 5 ln of 12 moves to the right. 3 ln of 6 stays where it is. We factor and divide. Now, if you're paying attention and if you're watching carefully, you can actually do what I call unwinding a logarithm. Let me try to show you. Keep in mind that this is the maximum of where you can be. So please, if you don't get here, I don't want you to stress. I just want you to know that you will at some point reach the level of ability where you can do this yourself. But it requires a lot of practice. Alrighty. So you'll notice I have a 5 ln of 4 here when I exponentiate. It's going to come out and it's going to move over as a minus. So we have a minus ln of 12 plus 4 ln of 17. And we're going to subtract a 5 ln of 4. The denominator has to be this minus 2 ln of 4 plus 2 ln of 9 minus 2 ln of 12. We're done. Now notice it went very quickly. We just had to watch where everything went. When I have an x, that's going to be in the denominator. So this 4 to the negative 2x and 9 to the 2x are sitting in the denominator here and here. 2 ln of 4, it's a negative, and 2 ln of 9. This piece right here has to be 2 ln of 12, and when it moves over, it becomes a minus. This is a positive 5 ln of 4, and it's going to come over as a minus. This is already a minus 1 ln of 12 and a 4 ln of 17, and they're separated by a plus. So that's the idea of unwinding. Let's try one more for unwinding, and for those of you who are still practicing, be aware that this is what you're going to ultimately practice to get down to. You want that solution right there. Here we go. 2 to the 7x plus 4, 11 to the third, 3 to the second minus 5. Let me check that again. That's a 3x. And then 13 to the seventh. Notice this piece right here is a positive. It's 2 ln of 3 plus 7 ln of 13. Notice neither one of them has an x. This piece is a minus 3 ln of 3, which will be in the denominator as a plus 3 ln of 3. This 3, 11, is going to come to the other side as plus 3, wait a minute, minus, it has to change to its opposite, minus 3 ln of 11. And you'll notice I have a 4 ln of 2, which is going to come over. And then this has an x for 7 ln 2. There's the x, unwound. That's what we're looking for. All right, Hornets. This is solving large, complex exponential equations where you have exponents on both sides and you have to exponentiate in order to solve. Please, you have 2 that you can do and find your answers to if you wish. And I do recommend that you practice and then take a look. For those of you who wish to learn more about this unwinding process, please give it a try, practice enough, and if you wish, come on in and ask me questions, and we can do a few of them in class. Thank you very much, Hornets. I hope this has helped you. If you liked this video, please remember to click like, and hopefully you have subscribed. Thank you very much. Be well, take care, and have a very good and safe evening. Bye-bye now.